For this video, what I want to do is show you how to run a 1 proportion z test in the TI-84 graphing calculator in order to get our p-value and the answer to our standardized test statistic z. I am going to show all of the mechanics that go along with a 1 proportion z test because it's really important that you understand the work behind it, and a lot of professors or teachers require you to show out all the work, including the conditions. So when we are going through this, I know that I identified the video as being a 1 proportion z test, but you're not always going to have that information. So knowing the conditions helps you to trigger when to use specific hypothesis tests. So what we have here is a medical researcher claims that less than 25% of US adults are smokers. So because of the fact that I have a percentage or a proportion of a population, that needs to trigger that I'm going to run a test for proportions. Because I only have one sample and I'm not comparing 2 samples, I'm going to use the 1 proportion z test. So that's what should trigger it. So in a random sample of 500 US adults, that gives us our sample size, 19.8% reply that they are smokers. So this is our p-hat. This is our sample proportion. And sometimes they will give us the sample proportion, and sometimes they will give us the number of successes out of the total number, and you have to find the p-hat. So at alpha equals 0.05, is there enough evidence to support the claim? All right, so let's start with the conditions. The first thing that we should always look for, no matter what hypothesis test that we are doing, is that we used randomization. So we used a random sample of US adults. The second condition that is used is that n times p has to be greater than or equal to 5, and n times q has to be greater than or equal to 5. This is the condition that allows us to use the normal distribution to approximate a discrete probability distribution. Okay, so this was a binomial distribution because we're talking about people, and people are either going to say yes or no to the question of, are you a smoker? So in order for us to be able to use the sampling distribution of the sample proportions, or the central limit theorem, we do have to make sure that this condition is met. So in order to do this, we need to find n, and our n, like I said, was 500. Our p comes from whatever the claim is. So since our claim is 0.25, that is our p, and then q is always 1 minus p, so we would end up with 0.75. We would then take and plug those values in. So we would say 500 times 0.25. That ends up giving us 125, which is greater than or equal to 5, so that one's met. We do have to check the other one, and then the only way that your teacher or professor knows that you graded, that you checked these, is if you write them down. Okay, checking them in your head doesn't work because whoever's grading your work can't see that. So always just write the conditions down. And I'm also just going to throw out there that there are some other conditions that show up in different textbooks. So just check your textbook to make sure that all of them are met. There's different versions of conditions, but these are the 2 most important. All right, so we will use this information again, so that's why I'm circling it, when we get into finding the standardized test statistic. Okay, so since our conditions are met, we can use the 1 proportion z test. Okay, so we only have 1 proportion that we're comparing to the claim, and it's always z with proportions. So we're going to use the 1 proportion z test. Our next step is to set up the null and the alternative. So it doesn't matter what hypothesis test you're using. After you've decided that the conditions are met, then you're going to find the null and the alternative. And this comes from the claim. So the claim is that less than 25%, and so since we're using p, we would use p less than 0.25. Okay, since we have a statement that is less than, we would have to put this in the alternative. So we would say that P is less than 0.25 and identify that this is our claim. Because at the end of this, when we interpret, if our claim is about the alternative, then we're going to use the word support. If our claim is about the null, then we're going to use the word reject. Okay, the null hypothesis is always the complement, so we would use greater than or equal to 0.25. The alternative always helps us determine the tail of the test. So this would be a left tail test because it's less than. Anytime that it's left tail, that means, or anytime that it's less than, that means that the left tail will be shaded. Okay, so our next step is to actually draw out the model, which is just a normal model. And I'm going to label this with the p-value because I'm going to use the p-value decision rule, as well as the standardized test statistic that I get after I run it in the calculator. So to find z, our formula is p hat minus p divided by p times q over n. We've already established that n is 500, p is 0.25, and q is 0.75. So the p and the q always come from the null and the alternative or the claim. We needed those for the conditions, so we'd already written them down. So let's go back up into the problem and find the p hat, which we had already identified as 19.8%, and we always put this as a decimal. If they had given you, so I'm going to go ahead and write that down, p hat is 0.198. If they give you the number of successes, and I do have a video that shows that, but if you're given the number of successes, then you would do x divided by n to get your p hat. But they gave us p hat this time, so we don't have to do that. We are going to have to find x in order to use the calculator. So to do that, all I would do is multiply both sides by n. So we would do n times p hat, and you can just do this in your calculator in order to find x. So I will talk about that when I get into the calculator. So let's go ahead and plug in our information. So p hat is 0.198 minus 0.25, and then we would divide this by the square root of 0.25 times 0.75 over 500. So instead of having to plug this into your calculator, what we can do is run the one proportion z test, and it will give us the approximation for z. Okay, the one thing that I did forget to write down was our alpha level, and it did tell us to use alpha of 0.05. We need that to compare to our p-value to make the decision, and you always want to decide your alpha level before running the test. All right, so let's grab our calculator. To get there, what we're going to do is we're going to hit stat and go to tests, and then we're going to choose the one proportion z test, which is option 5. P naught is the value or the proportion that is in the null hypothesis. So in this case, we had 0.25 in our null hypothesis. X, like I said, is n times p, so n is 500 times our p hat, which is 0.198, and then we hit enter. If this is not a whole number, if I got something like 99.2 or 99.3, then I do have to round this to the nearest integer, because since this is a binomial distribution, binomial is discrete, which means that I can't have fractions or decimals for my number of successes, because a partial person cannot say that they smoke. They either do or they don't. Okay, and then n is 500. When we get down to this part here, this always needs to match the alternative. So since our alternative is less than 0.25, we would select less than p naught. So p naught is the value here. So we're selecting that our proportion is less than 0.25. If you have the color calculator, you can go through and choose different colors. If you don't have the color calculator, then you get the grayscale. And I'm going to go ahead and draw it, and the reason I'm going to draw it is because it will actually shade my p-value. It will have it centered at 0. This would be -1, standard deviation is -2, -3. And so we can see that our p-value is 0.0036, and our standardized test statistic is -2.6853. Okay. With this, remember what the p-value is. This is nothing to do with the proportion in the problem, the p in the problem. This is the probability of getting this standardized test statistic or something more extreme. Okay, so if we shade this, this is going to be our p-value, and we can see that we're not shading very much. 0.0063 does not shade very much, and then we would label this as negative 2.68. And over here we would put negative 2.6853 for our standardized test statistic. And our p-value, like I said, this is the probability that our standardized test statistic z is less than negative 2.6853. You could also write it as p, the probability of our p hat being less than 0.198. Okay, so this ends up being approximately 0.0063. Now the decision rule that we are using is our p-value decision rule. So to make our decision, we're going to compare the p-value to alpha. So we can see that our p-value 0.0063 and our alpha 0.05, this is definitely less than. So if it's less than or if it's equal to, then you always make the decision to reject the null hypothesis. Okay, if it's greater than, then you fail to reject. So now we have to look back at our information up here, and we see that our claim is about the alternative. So since we're rejecting the null, we're saying this doesn't appear to be true, and the evidence is actually pretty strong. Our evidence is pointing to this being true, which means that it's pointing towards the claim being supported. So the way that we would interpret this is we would say at 5%, because that's our alpha level. Instead of saying alpha equals 0.05, I usually say at 5% because more people understand that. We have enough information or enough evidence to support, so we're going to use the word support, the claim that less than, and all I'm doing is rewriting what was in the original problem. So the claim is less than 25% of US adults are smokers. So that's all you have to do so that you give the context. We have enough evidence to support the claim that less than 25% of US adults are smokers. Okay. I understand that this is a very lengthy process, and I know that some teachers and professors and homework applications are okay with you just putting in the numbers, but it really is important to understand the entire mechanics of what goes into a hypothesis test. So any hypothesis test, you should always start with conditions to see which test you're going to use. Identify the name of the test. State your null and your alternative, and then show the work for finding the standardized test statistic, as well as drawing out a model of either your p-value or rejection region. Both decision rules will give you the same answer. And then interpret your decision in context of the original problem. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.